In this example, we will find a solution to the initial value problem y double prime plus y prime minus 12y equals 0 with initial conditions that y of 0 is 2 and y prime of 0 is 1. To solve the initial value problem, we should first solve the differential equation y double prime plus y prime minus 12y equals 0. And to find solutions y equals e to the rt, we can solve the characteristic equation r squared plus r minus 12 equals 0. And we can compute the solutions by factoring r squared plus r minus 12 as r plus 4 times r minus 3, which gives the values of r to be negative 4 and 3. So we can conclude that both y1 equal to e to the negative 4t and y2 equal to e to the 3t are solutions. And furthermore, that any linear combination of them are solutions as well. That is, y equal to c1 e to the negative 4t plus c2 e to the 3t, where c1 and c2 are constants, are also solutions to the differential equation. And now, to solve the initial value problem, we need to use the initial conditions to find what values of c1 and c2 fit those initial conditions. Imposing the initial condition y of 0 equals 2, we get that 2 equals y evaluated at 0, which is c1 times e to the negative 4 times 0 plus c2 times e to the 3 times 0, but e to the 0 is just 1, leaving the right-hand side as c1 plus c2. To use the initial condition y prime equals 1, we need to compute the derivative of our function y. The derivative of y equals c1 e to the negative 4t plus c2 e to the 3t is negative 4c1 e to the negative 4t plus 3c2 e to the 3t, which, with the initial condition y prime of 0 equals 1, yields that 1 equals y prime of 0 equals negative 4c1 plus 3c2, since again e to the 0 is just 1. And using the equation 2 equals c1 plus c2 from the first initial condition, we get that c1 equals 2 minus c2, which can be substituted into the second equation. Doing this, we get that 1 equals negative 4c1 plus 3c2, which we'll now rewrite as negative 4 times 2 minus c2 plus 3c2. And simplifying the right-hand side, we'll have negative 8 plus 7c2, leaving us with the equation 1 equals negative 8 plus 7c2. And then by adding 8 and dividing by 7, we can conclude that c2 is 9 over 7. And since c1 is 2 minus c2, we get that c1 is 2 minus 9 over 7, which is 14 over 7 minus 9 over 7, giving 5 over 7. So we can conclude that the solution to the initial value problem is y equals 5/7 e to the negative 4t plus 9/7 e to the 3t.